Hi guys, today we are going to be on pages 5 and 6 in our notes. We've been introduced to what a system is, and now we're going to make sure we understand how to do it completely by graphing. So pages 5 and 6 look something like this, and we're going to go along with those together, and then there will be a practice assignment for you guys to complete. Okay, so when solving a system of equations by graphing, it's often easiest if both equations are written in slope-intercept form, because that's usually our favorite form. In A and B below, graph to solve the system, then answer questions A and B. Okay, so A has y equals 2x minus 1, so this looks like it is easy to be graphed. So we are going to start at -1, and we're going to go up to right 1, up to right 1. Then we're going to go back to the starting point and follow the pattern backwards. Okay, now with the second one, -4x plus 2y equals 4, it doesn't look like it's in slope-intercept form, so let's transform it to make it look like that. So I'm going to move this -4x over to the other side, okay, with a positive 4x. Again, we're at the point where you might have to write it, you might not. Do whatever makes sense to you guys. 4x plus 4. Okay, now I'm going to divide by the 2. Y equals 4x divided by 4 is 2, and 4 divided by 2 is 2. So we have the equation y equals 2x plus 2. So to graph that, we would start at 2, and we would use the slope 2 to 1 to graph it. Okay, so I'm going to actually draw the lines to kind of visualize this a little bit better. Okay, but what I notice is they never cross. Okay, so we'll talk about what to do if something of a line never intersects. Okay, graph B. Y equals -x minus 2. So this one looks like it's ready to graph. Start at -2. The slope is -1. So we'll go down 1, right 1. Now I'll go backwards and connect it with a line. Okay. Now this next one does not look like it's in slope-intercept form, so I'm going to solve it to do that. So I'm going to move this 6x, it's a positive, so I'm going to move it over with a negative. Okay. Then I'm going to divide by the 6. -6x over 6 is -1. -12 over 6 is -2. Okay, so I start at -2. I go down 1, right 1. Oh, it's the same exact line. Weird. Okay, so what do you notice about the lines in problem A? Okay, well, we said that they never intersect. Okay, so if they never intersect, there's never going to be a point that's a solution. So this means there is no solution to this system. Okay, what do you notice about the lines in problem B? Well, they were the exact same line. Okay. And if it's the same exact line, that means that whatever's on this red ordered pair would also be on the blue ordered pair. So every single point that's on the red line would also be on the blue line, which would mean that this has an infinite number of answers, since it is the same exact line. So you remembering stuff about equations, this now comes into effect when we solve a system. Okay, so there are 3 different types of solutions we can have with solving a system. We could have one solution, we could have no solution, and we could have infinitely many, just like when we solved equations. Okay, if a line has different slopes and and they will intersect at one point. Okay. So something to notice about the ones that were parallel or they never crossed, you notice that they have the same slope, they have the same steepness, but they started at different points. Okay, so lines that have the same slope but different starting points or different y-intercepts, they're never going to cross. So that means it would have no solution. Okay. Then part B, we notice that they have the same slope and the same y-intercept. They're the exact same equation. So lines that have the same slope and same y-intercept, which means they're the exact same equation, would have infinitely many solutions. Okay, so we're just going to continue making sure we feel comfortable with solving by graphing, and then just sometimes we might have a situation where we would have one solution, no solution, or infinitely many solutions. Okay, so number one, we have y equals 1/2 x plus 4. So this one looks like it's ready to graph. So we're going to start at 4. And we're going to go up 1, right 2, up 1, right 2, and keep following that same pattern. Then I'm going to go backwards. Okay. With the second equation, x plus y equals 7, it does not look like slope-intercept form, so I'm going to solve it. Okay, I'm going to move this positive x over with a negative x. And there's nothing for me to divide by, so I'm ready to graph it. So I'm going to start at positive 7, and I'm going to go down 1, right 1, since it's a negative x. And I see that it crosses right there. So I could stop, but I'm going to graph all the way across. Okay. So this solution is right here where they both cross, and that would be 2, 5. Okay. Something to notice is if I just look at these two equations, they have different slopes, and if they have different slopes, that means they're going at different steepnesses, so eventually they will cross no matter what. Okay. Go ahead and try number 2. Hit pause, and then whenever you're done, hit unpause and see if you get it right. All right, so this one, y equals 3/2x. It starts at 0. You go up 3, right 2. And then you go backwards. Okay. Then for the second equation, negative x plus 2y equals negative 8. We're going to move this negative x over with a positive x. Then we're going to divide by 2. Y equals x over 2 would be the same as a half of an x. And then negative 8/2, which would be negative 4. Again, before I even do anything, I notice that their slopes are different, which means I know that they're going to cross before I do anything else. Okay, so I'm going to start at negative 4, and I'm going to go up 1, right 2. Then I'm going to go backwards, and that looks like that's where it's going to cross. So the solution would be right here. So negative 4, negative 6. Okay. All right, go ahead and go to page 6 for me. Okay. Question 3 says, solve the system of equations by graphing. Okay, right now, neither of these are really graphable quite yet, so I'm going to basically just solve them for slope-intercept form because that is our most favorite way. So I'm going to move the 3x over with a negative 3x. Okay. Then I'm going to divide by 6. Okay. Negative 3x over 6 is equivalent to negative 1/2. And then negative 12/2 is equivalent to negative 2. Okay. I'm also just going to go ahead and solve this second one because I might as well just get that out of the way. Okay. I'm just going to divide by the 2, and I have y equals negative x over 2, which is equivalent to a negative 1/2, and negative 4/2, which is equivalent to negative 2. Okay. Something to notice, and if you notice it before you even graph, you notice that the slopes are the same and the y-intercepts are the same. So these are the exact same lines. So I don't even really have to graph this. This has an infinitely many solution. Okay. Which just means whatever is a solution for this one is going to be a solution for this one because they're the exact same line. Okay. I want you guys to go ahead and try 4, 5, and 6, and then hit unpause whenever you guys are done because 4 you could kind of have a lot of different answers for it. So hit pause, try 4, 5, and 6, and then hit unpause, and we'll go over these answers. Okay. The graph line below represents an equation in a system with no solution. Write a possible second equation for this system. Okay, so you could do a couple different things. Okay, I'm going to write the equation for this one first. So I know that the slope is negative 1 over 4, and it starts at 3. So I know that the equation is y equals negative 1/4 x plus 3. Okay. For it to be a no solution, which means it would never ever cross, okay, you guys could have to write y equals negative 1/4 x. But then you would have to write any other starting point besides 3. Because if you even started at 0 and went down 1, right 4, okay, it still will never ever cross. So as long as your equation has a slope of negative 1/4 x and then has a starting point anything besides 3, you got it right. Okay. Number 5, Tish believes that the linear equations shown do not have a solution because they don't cross. Do you agree? Why or why not? Okay, and so I totally agree. These do not cross on this graph, but these are eventually, if I extend this out, these are eventually going to cross. They're just not on the coordinate plane that is given to you. Okay, so I do not agree. Okay, they will eventually cross. Okay. Number 6 says, circle the names of 2 friends whose equations would have infinitely many solutions. So infinitely many means a whole bunch of possible answers. So I think of all the ordered pairs in the world, which means they need to have the same exact line. Okay, so I'm just basically going to start solving some of these and seeing which ones would have the same exact line. Okay, so I'm going to move Penny first, 2x. I'm going to move that over with a negative 2x. And then I'm going to divide by a negative 1. So this negative 2x would become a positive 2x. The negative 1 would become a positive 1. All right, for Ravi, I'm going to move the 2x over with a negative. Okay. And then I'm going to divide by 3. Negative 2 over 3. And then 3 over 3 is 1. So these do not match. These do not have the same slope. They do have the same starting point, but they do not have the same slope. Okay, so Courtney, I'm going to move this negative 4x over with a positive. And then I'm going to divide by a negative 6. Okay, so 4 divided by negative 6 is negative 2/3. Negative 6 divided by negative 6 is positive 1. Okay, if I notice that Ravi and Courtney have the same exact equation. Okay, so that means that they would have infinitely many. Okay, just to check, you could do Edwin as well. You would move the 6x over with a negative. And then you would divide by 6. You would get negative 1x plus 3 over 2. So that would not be a matching equation. Okay, number 7, Abby bought a combination of streamers and balloons for a birthday party. A number of balloons, Y, was 3 less than 2 times the amount of streamers purchased, X. If Abby bought a combination of 9 balloons and streamers, the following system can represent the situation. So here's the first one. The number of balloons, balloons is streamers. Streamers plus balloons equals 9 total things, okay? The number of balloons is 3 less than 2 times the number of streamers. So that's how they wrote this equation. So first we are going to just solve it by graphing. Okay, this one's not graphable yet, so I'm going to move it over with a negative. Okay, so I'm going to start at 9, and I'm going to go down 1, right 1. Okay. All right. Then we have this equation, which is already ready to be graphed. So starting at negative 3, going up to right 1. Okay. So where they intersect is right here, which would be 4, 5. And then just making sure that I know which is what. X is the number of streamers, so 4 streamers. And 5 balloons. Okay, so for today, guys, your assignment is on pages 7 and 8 right after your notes. And then tomorrow we will practice some more. So be ready to turn that in and grade it tomorrow. See you guys tomorrow.